Recording is on.
Well, you had a whole big presentation that was going to last 2 hours, didn't you, Eric? Yeah. Okay. Well, Eric's going to reboot. Did we want to get started, or did you want to wait for Eric? So, Dave, are you officially retired now? Yeah?
Good for you.
Well, that leaves Kevin.
Well, I'm starting this week. I'm not working Friday afternoons. Does that count? I'm going to start my weekends early.
Well,
and then maybe in the summer, maybe just not work Fridays.
Well, if you devote Friday afternoons to ham radio homebrew stuff, then yes, it counts.
Okay. That's the plan. I don't know how well it's going to be executed, but I'll try. Got to start somewhere.
Yeah.
I figure if I just fade away, maybe they'll just not notice me and I'll just, fade away into oblivion.
Yeah. Let me just.
Hey, Kevin, my last day, one guy showed up.
Really?
Yeah.
One guy showed up for your retirement party?
Yeah, one guy.
So, well, that's. I'd say I expect it to be zero. So I'm just gonna like I said, I'm just gonna stop coming in one day, and that'll be it.
Well, it wasn't really a retirement party. It's like I'm returning my badge. I'm returning my hospital equipment, and I'm done. And December 30th, I'm coming in. I went in. There was one guy there. Came in, said, "Hey, come and take you out for lunch."
What did you do, Dave?
Huh?
What did you do for a job?
What I do, I guess I pissed off a lot of people. I don't know how to answer that question.
Well, what was your job? Put it that way.
Oh, what's my job? Oh, I was the security officer for Scarborough Hospital.
All right. Okay.
Scarborough Hospitals.
I had two retirement parties. It was embarrassing. They had the first one, and the director couldn't make it out, but he wanted to be there, so they had to have a second one. I thought, oh my God, it was bad enough going through the first one. Then they had to do the speeches. They had to write an all new speech again.
Well, in other news, the James Webb Space Telescope is almost ready to go. It looks like.
Yeah, that was good.
They put out the telescope arm today. The secondary.
Yeah, the secondary mirror is up now.
I was just watching. It's very interesting.
Yeah, that's pretty cool, man.
It's going to be interesting to see that thing get deployed.
Yeah.
Yeah.
Might be interesting to hear. Okay, maybe we should get started without Eric then.
Eric's here. He was.
He was there, but he's gone again. I think if I was him, I'd sell that cottage. Okay, well, I guess we'll get started. I know Eric had something that he wanted to present as well. Oh, he's back again.
Can you hear me?
Oh, no, I can't hear you.
Yes.
I'm starting to feel like a 60-year-old or older man now.
Well, you definitely look older.
So this time it was the keyboard switch. Somehow it got, the soft key on the keyboard got clicked, and there's nothing on this computer that I'm using that tells me that it's toggled on or off until I start messing with it. So anyway, prosaic answer, right?
Yep.
Good evening, everyone. Sorry about that. What is it? 10 minutes in. Hey, that's not so bad for a captain last minute. So
we'll chat later about this.
Yeah. All right. So welcome to our AF Mixer for the first time in 2022. So Happy New Year to everybody. Hope you all had a good one. And onwards and upwards, or onwards and sideways, right, as I like to say. So I like to see that progress is being made in some circles. I see some plywood behind somebody's head there. So that was being discussed on New Year's Eve. So nice to see that, Dave, you got your project in the works there. Oh, look at that. Somebody's been busy. Holy cow. All right. No wonder he hasn't been responding to my texts and messages and all that. So anyway, good job. Nice to see. So here we are. I don't think anyone replied to the email that Peter sent out regarding topics that wanted to be discussed tonight, or a little informal presentation, but I know Peter's got something to talk to us about scope probes. So hopefully some of you noted his links and maybe even have some input to make on the probes, what they had a chance to muck with them a little bit. In keeping with my cottage hours here and cottage technology capabilities, just kind of like in my university days, I was 2 hours ago, got about halfway through the first LT Spice tutorial video. And that's about where it stands, because then, whatever, dinner duties and other things got in the way. So the year gets a real call sign. Maybe. Miracles can happen, Victoria, or however that goes. Anyway, so yes, I came across, I was reading not the most recent, but the penultimate issue of Sprat, and came across a 2-transistor transmitter that a British fellow, G4RAW, came up with that looked kind of interesting. It was simple enough for me to maybe get my head around. And I thought, let's figure out how to put this into Spice and see LT Spice and see what I can, do with it. So anyway, there it was. This plan just kind of only started coalescing in the last 24 hours. So didn't get very far, but I must say that I'm a little bit more familiar with the program now, but not enough to really talk about it. So I think that's going to have to wait until 2 weeks from now at our next meeting. Honestly, that's really the only way to do it justice. But anyway, looks like actually an interesting project to put together. So I mean, it's simple, but that's the kind of thing that I'm looking for. I noticed your post a few hours ago, Peter, about the LT Spice, I guess, demo for the Pixie transmitter. I don't think anyone came back with weighing in on that, but maybe that had something to do with what I was talking to you about earlier, messaging you anyway. So, all right. So does anyone have anything else that they want to put on the agenda for this evening that they wanted to chat about, or anything semi-formal? Going once, going twice? I know Dave's going to want to talk about his project that's going on there, his construction project. So we can kind of put that on.
You want to talk about plywood?
Plywood, yeah.
Oh.
Well, I just want to, like how many times he's hit his thumb with a hammer and, stuff like that. So, all right. Anyway, so I think that's about it. FDIM has opened up registration for those that maybe didn't notice. I think Dave made a posting about it. So that's of significant interest to the group there. Those that are, I guess, still waiting and seeing what the lay of the land is going to be like as far as international travel goes. Obviously, if it was happening this month, I don't think anybody would be going, myself included. But, 4 months from now, I guess it might be a different situation. So we'll see. Maybe we'll have 6 administrations of the vaccine by then, and we'll all be, super robust and ready to go down. Who knows? But anyway, remains to be seen. But for what it's worth, I would suggest registering for that, because even if it isn't happening, or you're not going in person, they are going to be streaming it just like they were last year, making the proceedings available in soft copy for sure, probably hard copy as well. I think everyone who did watch it last year virtually, was happy with the presentations. So something to put in your bookmarks and sign up for. Plenty of time to do it, of course, but that's it. I don't think anything has been mentioned about Hamvention as far as registration being open for that. I don't believe that's happening, but I'm sure they're planning for it to be an in-person event. From what I gather, anyway, lay of the land in Ohio is pretty open to events, from what I gather. So, all right. Anyway, so that is that. I guess we can get started with tonight. And Peter, you've got something to talk to us about with regards to probes. You have some findings.
Yeah, disappointing findings, to be honest, but or really interesting. I shouldn't say disappointing. Every finding is something, right?
For sure.
We can see that.
Yep.
What's the expression? You learn more from your mistakes and failures than you do from your successes, right?
Yeah, something like that. Okay, so I can't remember exactly what got me onto the probes this time. I think it had something to do with a video I watched with, I don't know if it was Dave Jones or maybe it was an LT Spice simulation that somebody brought up or a few weeks ago about probes. So I thought, well, let's look into this a little bit deeper. I've never really took a close look at my scope probes. And I thought, well, let's have a go and see what happens. I don't know if anybody else had a chance to do it, but I think you'll see. If you haven't, I think you will after this. So what I used, well, okay, in the upper left, those are the probes I used, the ones that came with the Signet. Take note of the bandwidth on it, 6 megahertz when it's in the ×1 position, and 100 megahertz in the ×10 position. I did do some scans with the PARC SNA, and the other instruments I used was the spectrum analyzer and Agilent signal generator. So on the left is the 10 times probe, and on the right is the 1 times probe. This scan is 1 hertz to 1 megahertz. So if you look at the 10 times probe, it's you can see when you're down near the real bottom end there, it's pretty flat. From if I don't have the screenshot of it down in the lower frequencies, and then it takes a big dive down, as you can see. And at the number 2 spot there is about 310 kilohertz at 55 minus 55.5 dB, and when you get up to 1 meg, it's at 46.8 dB. So there's a fair swing on that. 40, let's say 47, so about 7 dB. And on the right, the 1 times probe has that little, at the very beginning, the lower, for very low frequencies there, the 1 hertz area to, I forget how now. It's pretty flat, and then it dives down, and then it's pretty flat right across the whole thing there at minus 15.8, 15.68, all the way across up to, in this picture anyways, 1 megahertz. So on this one here, although the scale looks a little bit different on there, but on the left, the 10 times probe, I'm now doing 1 megahertz to 30 megahertz. And you can see quite, the marker table, you can see the numbers there. At 30 megahertz, we're at a little over 22.5 dB, minus 22.6 there. And if you look at the number 2 marker at 10 megahertz, so you're at 28. So that's still a fair change. It isn't until you get
Peter. Michael has his hand up. I think he's got something to ask at the moment.
So I don't see it when somebody puts their hands up. I don't see it when I'm in the presentation.
Right,
so
right.
Take care of that here.
Okay, Peter, what's the amplitude? What are you measuring on what's the vertical scale? You're measuring something. What is it?
I
it's minus 46 dB. What's that a measurement of?
This here?
Yeah.
That's dBm.
Yeah. So what are you measuring? What are you measuring with the scope?
Oh, okay. I'm measuring the probes. I took my 1 times and 10 times scope probe, and I stuck it on the input and the output I'm running a tracking generator on the spectrum analyzer.
Okay, good. Thanks. That's fine.
Sorry
Thanks.
about
Okay, no problem.
Yep. And Dave's got his hand up.
that. Yeah, Dave.
Hey, did you normalize your sweep?
Yes, I did.
Because
On more than one occasions. And when I changed the frequency range, I redid the normalization as well. So when I was going from 1 hertz to 1 meg, I normalized. And then when I went from 1 to 30, I renormalized it.
And how much attenuation did you have?
It looks like the 20 dB attenuator.
There it is, log 10. No, it says log 10. Doesn't say, oh, attenuation 20. So you're using 20 internal.
Yes, no external attenuation. And I think I had the thing set at 0 dBm, if I recall.
Yeah, you're running it pretty hot.
Yeah, and I did do a very quick one at a lower value, just a quick comparison, but I didn't record the stats of that. They were pretty much, the graphs were pretty much the same. So again, the 10 times, is there any other comments?
Peter, no, there's no.
Okay. So the 10 times probe, like I say, it doesn't start to settle down a little bit until you're, into the 20 megahertz range. It starts to flatten out a little bit up to the 30, but everything else leaves your head scratching, at least for me anyway. The 1 times probe though, it's still hanging in there. It's supposed to have a range of a bandwidth of 6 megahertz, but it's going along pretty good. 12, let's see, we're at 12 and a quarter, 12, 13, 14. So we're still all the way across the HF band, and then a good chunk of below the HF band as well. It's still within the 3 dB part.
Peter, Dave's got his hand up.
Yeah, Dave.
Hey, does 10, a factor of 10, does it equate to 10 dB? I think it does, doesn't it?
I think it does. Let's see. If you go there's minus 50.
If you look at,
let's go up around the middle, somewhere around 20.
no, because if you look, Peter, M2, M3, M4, there's a difference of roughly about 10.
Yeah. Yeah.
So it's just the M1 marker where it's rolling off at 1 megahertz.
Yes.
So 2, 3, and 4 is pretty consistent for a times 10 probe. If 10 times 10 is equal to 10 dB, I believe it is.
Yes, I see what you're saying. You got the 10. Yeah, in that regard, yes. But if you're looking at, say, from 10 megahertz to 30 megahertz, you're looking at 5 or 6 dB change, right?
Yeah, but don't forget, you got your clip-ons. It's not a BNC connector. You're using the clip-ons, right?
Yes.
And so that's going to introduce some loss. So I think this data is not bad. If you look, because it's roughly, marker 2 is 28 and 14. So it's a little bit more than 10. Marker 3 is 24 and 13. That's almost 10. And marker 4 is 22 and 12. That's 10.
Yeah, no, I know what you're saying, Dave. That's fine. But if you go back to the 10 times probe, if you look at what you're at 10 megahertz, you're at 28 minus 28 dB. Now you go up to 30 megahertz, and now you're at 22 and a half. You're about 6 dB change there.
Yeah, but can you look at the difference in frequency? I don't think it's linear. I don't think it's necessarily linear, because that probe is made up of inductances and capacitance, right?
Right.
If you look at Dave Jones's and Electroboom's videos where he models it, it's all, inductances and capacitance. So of course you're going to get some roll off, right?
Yeah. Well, it's interesting in that how flat the one times probe is, I think. Because you're not getting much of a change in the dB there at all. You're still within a couple of dB. But anyway, I know what you're saying. I just, here it looks like so far the 1 times probe has far better results than what it was spec'd at 6 megahertz. But the 10 times probe is supposed to have 100 megahertz bandwidth, but I have not seen it yet. At least not up until 30 megahertz anyways.
So Peter, dumb question, but I presume that that's the trade-off for the 10 times, right? You sacrifice some
I don't
of that.
know. I just was curious to see how the probes would perform. So this is why I was doing this. And I expected to see a better performance on the 10 times probe.
Right.
Than what I'm observing here, especially since, well, anyway, let's go to the next slide because it does, you can kind of see here where the 10 times probe is flattening out now a little better at this now range here is 30 to 100 megahertz. And you can see now we're up around, let's see, 19, 21, 20. So there's a 3 dB drop between 30 megahertz and 75 megahertz. So it's flattening out at the higher ranges. So I guess let me just go back. So if you at say around 20 megahertz is 24. Yeah, 24, 22, 20. So, you know, a little bit more than 20. So probably, you know, upper HF, very upper HF up to 100, up to about 75 megahertz it's flattened out fairly well within 3 dB anyway.
Yeah, the interesting thing, Peter, if you look at M4, 100 megahertz,
Yeah.
you're off by what? Not even a dB there. So it flattens out between both probes, but one's a times 10 probe. So something's squirrely.
Nah, you won't get an argument from me. It's interesting, that's for sure. Exactly why, who knows? But again, now the 1 times probe is hanging in there pretty much. It doesn't really start to change much until it gets to about 75 megahertz, 76 megahertz, and then it has its change. So really, from about 300 kilohertz or something like that, maybe a little bit less than 300 kilohertz, all the way up to about 50 megahertz for sure. Well, 3 dB would be up to 75 megahertz. That's the 1 times probe. The 10 times probe, that's a different story.
Yeah, the other thing too, Peter, the SA assumes it's a 50 ohm load.
Yes.
Right? So I don't know what that's going to impact in terms of SWR and all that crap, you know. So you're feeding not a 50 ohm load with the 50 ohm load and a scope probe. I don't think.
You're right. I had not thought of that. See, why didn't you have this conversation with me a couple of weeks ago? You know what? You're right. There would be a mismatch there, wouldn't it? Because in this case here, in my case, the scope, I can't change it to 50. It'd be 100. It'd be a 1 meg input. Well, so I'll probably have to rerun some tests tomorrow.
Yeah, because I think at the input end of the probe, isn't a scope probe, is it 1 meg or 10 megs or what's the?
No.
It's
If you measure your probe, your scope's probe in the 1 times position, I think you'll end up with around 400 ohms.
No. What's the internal impedance of your scope? So that BNC jack.
1 meg. 1 meg to
meg.
ground.
Yeah, okay, so it's megs. So
it's 1 meg to ground in the scope.
Right. So then the BNC connector of your probe is supposed to be at 1 meg.
That's right.
Right. So Peter, what you need to do then is to get a transformer to go from 50 to 100, 50 to a meg, and then take the other end of the scope probe and terminate it with 1 meg or something like that. Right.
Yeah. On the spectrum analyzer, you mean?
No, the probe itself. Probe the actual, like right now, how are you probing it? Do you have the clip end shorted?
I did it both ways, but but all the tests in the end, I just went with the clip. I didn't use the spring.
Yeah, because
there wasn't a huge difference, Dave, to be honest with you, with the spring.
Yeah, I don't know, Peter. I'd have to.
Yeah, I know what you're saying about the impedance mismatch at the other end. I'll have to take a look at that going forward on it. But still, nonetheless, you would be. But you know, when your scope, well, in a way, you could be saying this would be happening if you're like your scope, for example, Dave. You can select the 50 ohm input.
No. My scope is not 50 ohms.
Well, you can't select 50.
No, it was a bug in the firmware.
Oh, okay. But anyway, well, I'll take a look at that this week.
Yeah, on my scope it says 1 meg and 18 picofarads.
Yeah, I think I remember now. You had a selection for 50 ohms, but it was in air, right?
Right. It was a firmware bug. They put the firmware on my scope for the scope that had 50 ohm choice. And so I had to go and downgrade the firmware. Once I put the proper firmware on, I couldn't select the input impedance.
Oh, okay.
I got the same 200 meg scope that Dave does, and it just says 1 meg, 18 picofarads. And I looked at this as well. You can't change that.
Yeah.
You can't go to 50. There's no
I think
selection.
you gotta go up to the next model up in order to have that. But there's a way around that anyway. So out of curiosity, I also had a Tektronix probe, and I just did a quick scan on that one there. So it actually performed quite a bit better than the Siglet.
So what is this telling me? Is this telling me that this is the attenuation across the probe, the length of the probe itself? Is that what this is all about?
Yeah, I've got it connected, like I say, to the tracking generator. So one end of the probe, I'm injecting a signal, and the other end, I'm measuring what's coming out, and I'm doing that across whatever frequency in this case here, I'm going from 1 meg to 30 meg on this slide here. So, and it's just plotting the amplitude that it's reading coming into the spectrum analyzer. So you're seeing the results of the frequency response, if you will, of the probe across that.
By putting a signal into the probe ends.
Yes.
And measuring what comes out of the BNC at the other end.
That's correct.
In terms of relative amplitude. So when you're talking, I don't know, 4 dB down, that's what you're saying.
Yeah, I wasn't really worried about whether the actual values like minus 18, minus 20, minus 15. I wasn't really interested in that one. I was interested in where does the probe roll off? Like where's the 3 dB points from the, across frequencies of interest. In this case, really the HF band. And, if you look at here's the Tektronix probe, and from 2.5 megahertz to 30 megahertz, look at the difference there. You're going from minus 34 to minus 18, or minus 19. That's
Peter, is this the same with the 10x on the left?
Yeah, 10x on the left. Sorry.
Yeah, Peter, this is showing that at 1 megahertz, you've got an amplifier.
Yeah, I know. I'm not sure what happened there, Dave. By the time I noticed it, I was all done and dusted, and I didn't go back to take a look.
So
but
it's some kind of resonance you've got.
I think there's some noise or something was going on.
No,
I
don't think it's noise. I think it's you got some kind of resonance happening there.
And this one was this slide here was actually a little bit earlier than the Siglet ones, and I never noticed that problem when I was doing it again with the Siglet probe. So I'm not too sure what went wrong there or what was going on there. But the values say, like, when you're looking at the markers from, say 2.5 megahertz up to 30 megahertz,
So does this mean that on the left-hand side, it means that you got minus 19 dB almost at 30 megs, you've got minus 34 at 2.5. That means that there's less roll-off at the higher frequency, right? Less attenuation, is that what that means?
Yes.
Okay, so it's better at 30 than it is at 2.5.
Yeah, what I'm finding is with these probes, there's less. There's a little flatter at around, say, 20 megahertz and above, kind of thing in that area for the 10 times probe. But now, as Dave pointed out with the mismatch, I'll take another look at that. I suspect it's not going to make a huge difference, but I'll definitely report back.
Wayne had a question.
Yes, Wayne's got his hand up.
What was the instrument you're using to take these measurements on again?
The spectrum analyzer from Siglet.
Okay. So what's its bottom end in terms of frequency response?
9, I'll tell you in a sec. 9 kilohertz.
Okay, so that's basically invisible. All right. I see the same kind of response on my my instrument, and generally you can't take readings below a certain frequency. That's what I was asking.
Yeah, in this case here, it's like 9. You can set your the settings go. You can set at 1 hertz and stuff like that, but the spectrum analyzer can't do any reading below 9 kilohertz, or at least that's what it's spec'd at. Okay, so I took the signal generator and I just kind of redid the thing manually. The top line is just a straight cable, and then 1 times probe is red, and then the 10 times probe is the yellow. And this one, I just took the signal generator and I just went through the frequencies as noted there: 230, 49, 60, and 75 megahertz. And then I just recorded the value in there. That's kind of, and again, you can see between 2 megahertz and 30 megahertz, it's a fairly sharp rise on that scope or on that probe. But anyway, I was just doing this to take another look at the same thing and from a different angle.
Peter Dave has his hand up.
Yeah.
Hey, I got a question for actually Wayne. Wayne, it's an interesting comment you made. Could you not, if you set your tracking generator to some value, say 0 dBm, you fed it into the SA and you did your sweep, but you don't normalize it. So you're actually looking at what signal the SA is seeing. So down at 1 megahertz, that would tell you if the signal, if the spectrum analyzer is rolling off. Could you not do that? Do you understand what I'm saying?
Not quite certain, but I think what I understand is the purpose of the normalization is to take the SA out of the equation. So you're actually only looking at the things it's connected to.
Well, it's making it relative. It's making it all, it's making the lines, it's taking out any of those fluctuations in the SA. So if you didn't take those, if you didn't normalize it, that would be giving, and if the tracking generator is giving, say, 0 dBm at 1 megahertz, 0 dBm at 10, and you're looking at what the SA is telling you at 0 dBm, if it's dropped down, then you know it's rolling off.
Well, what you would want to do is connect a cable between the input and the output of the tracking generator and the other connection on the SA. You normalize that. This is just a normal coax cable, right? When you normalize that, you have subtracted everything from the spectrum analyzer in terms of internal weird shapes. And that's when you connect the probe to it.
Yeah, but that's no. Forget about the probe. Totally different conversation. I'm talking about when you were saying about the SA might roll off below 1 megahertz because it's got bandwidth. And so it rolls off towards lower than 1 megahertz. What I'm saying is to measure that, could you not just connect that coax cable from your tracking generator to your SA, do not normalize it, and just see what the SA is seeing
Yes,
at 1 megahertz?
Of course you can. It's,
right? So
it's
that,
kind of low.
Yeah, that'll give you an indication of whether your SA is rolling off below 1 megahertz. Yeah, that was all. That was the question I had. So it's, yeah, we could do that, and that would help us understand the limitations of the SA, right?
I agree.
While we're chatting there, I just fired up the SA. I'm going to do that. I'm going to try that, Dave, and just see what happens. But I'm not quite ready for it just yet. But I will do that before the end of this meeting. So, did the same thing with the. Only this time I just did the PARC I used the PARC SNA just to see how it would look. And I guess really no surprises there, is there?
Yeah, it's pretty much, it's worse at the lower end, but it's pretty much the same, like above 10 megahertz, right?
Yeah. Once you get above 10 megahertz, you know, if 20 megahertz for sure. Well, in this case, it's starting to roll. I mean, there is some differences, but I just got curious, you know, okay, you know, because not everybody has a spectrum analyzer and not everybody has a tiny SA either. But we do have, but there's a few PARC SNAs that were built. So there's something else you can use for it. I guess it also too, if you have the nano VNA, that would work.
Mm-hmm.
So after doing all this, I got to be thinking, is it active probe time, homebrew time again? Revive that project that I was thinking about, well, I guess a few years ago now. So this circuit here, I picked up off of our friend out in BC, Mr. Carlson's lab. And this is a circuit that he came up with. He purposely built this for, I think, around 45 megahertz, but it was pretty flat outside where he was speccing it. I can't remember exactly how low he got in the video. I'd have to look at the video again to see what it's like in the HF band, but it might be just to play with a little bit of the values to swing it into another area of interest. It's a 1-to-1 probe. It's a 1-to-1 probe design to go into 50 ohms. So those of us with the 1 meg input on whatnot would have to use a T with the 50 ohm terminator to use this one. His video on this is very good. He explains what each and every component is there for and why he used it. This one here, this was a circuit that I came up with quite some time ago, and I did do a quick run on it the other day, and it seemed pretty good, a lot better than I remember it, because if memory served me right, I wasn't happy with the circuit from the entire HF band, but the scan I did the other day seemed to suggest that it could be all right for that. Over on the far right here was a circuit that I got actually off of the Texas Instruments website. They had an LT Spice model for a scope probe, so I thought I'd throw that in there just to see what's going on there. But anyway, this was another circuit that might prove useful for an active probe. And for references, there's the references that I think are good for this topic, and I put them on the Groups IO there the other day. So that's it.
That's interesting, Peter. Very interesting.
I guess it's like anything, you know, it's another one of those things, you know your test equipment, you know. I never really thought much about, you know, if I'm measuring a signal at, say, 2 megahertz or 1 megahertz and stuff like that, and then I go up to 25 megahertz, I'm thinking they're all the values I'm reading. When I'm using a 10-to-1 probe, I'm thinking they're all comparable, but they're not. At least I'm getting suggestion now. Okay, I'll redo it with the impedance matching a little bit better at the other end. But it certainly is now the suggestion when you're using a 10 times probe from one end of the HF band to the other HF band, the values could not be are not necessarily.
Yeah, I find it odd, Peter, that you'll see videos of guys testing amps and testing stuff, and they're using their scope, and they're saying, okay, the output here is 3 divisions up, and it's 2.96 volts. It's like you can't even read that from the you know, display, and also too, you have no idea what the probe is doing.
Well, yeah, exactly. So anyway, so I think an active probe is on my list. It's moved up a few notches on the list now, I think.
This raises the question of, you know, if you take one of those little amplifiers that the Let's Build Something project was about. You take one of them was, let's say, a 40 meg amplifier with a, and you try to measure something with that at 7 megs on the 40 meter band. If you try to measure something with your scope, you can't rely on that result to be anywhere accurate at all, because of that's what it suggests, right? Maybe.
Well, yeah. Which one's the accurate measurement? If is 7 megahertz an accurate measurement with your 10 times probe, or is 20 megahertz the more accurate one?
Yeah, but I got a 40 meter amplifier, so it's designed to run on 7 megs, right?
Yeah.
So you go through all the calculations and you say, well, it's I don't know, 10 dB gain or 14 dB gain, whatever it happens to be, and then you try to measure that. Well, you're lucky if it's what you're seeing is anyway accurate compared to what it should be, right?
Well, yeah, I mean, using 7 megahertz as an example, because of what I saw on the roll off at those frequencies, does that mean my measurement, measuring something at 7 megahertz with my scope, I'm severely under measuring?
Well, what's weird about that
level is actually quite a bit higher than what I'm reading.
What's weird about that is I think, if I remember correctly, I actually built one of the amplifiers and measured what the gain was and how I did it. I connected the scope to the output and connected the scope to the input, and saw the difference. The voltage gain works out to whatever it is dB, and it was right.
Yeah, but that's not the same as measuring the absolute value, Michael. I mean,
relative measurements are one thing, but absolute, like you say, Wayne, that's a whole different kettle of fish.
Mm-hmm. And the other thing is,
okay, with relative measurements, if that's more majority of the measurements I make is you're starting at one end of the circuit and you're measuring the different stages, the values of different stages. Well, okay, well they're all relative, so they're all meaningful. But when you get to the PA, now you're probably quite interested in what the absolute value is.
I'll get philosophical here. What exactly is an absolute measurement? Aren't all measurements relative?
What do you mean by what are you doing when you're talking about absolute measurement? What are you talking about?
Well, what I'm saying is, if let's say you have, for the sake of the argument, 30 volts peak to peak on the output of your PA, is it really 30 volts peak to peak there? Or is it because at 7 megahertz, your probe is attenuating the circuit much more, so you're maybe only reading 20 volts peak to peak, but in reality, you've got 30.
Yeah,
so that's where I'm saying the absolute value is important. But if you're going through the various stages of your circuit, you can see the gain, the relative measurement as you're going through the various stages are relevant to each other. They're meaningful because, they're all being attenuated by that same amount, right?
Got it. Yeah, that's right.
And you don't really worry about it too much, at least not that stage. Not like you would be on, say, the final output of an amplifier.
I have a tiny SA that I've never used, and I have the Nano VNA, and I also have the PARC signal generator. I'm going to play with this and see if I can figure something out here.
Well, that's why I kind of did a little bit of an advanced notice, thinking if anybody had some time, especially the newly retiree guy, it could have done some measurements, and then we could have had some comparison.
Well, I've been too busy thinking about Smith charts, Peter.
Yeah, I think there was a couple.
We have Dave up.
Dave,
question.
Do that. I'm gonna hook up the cable on the SA here that Dave was talking about earlier and just see what happens. So I'll turn up the volume so I can hear you guys. Oh, just a second.
Yeah, I think Eric, you're right. All measurements you make, they're all relative. Because what's a volt? It's relative to what a volt definition of a volt is, right? What's a meter? It's a definition of what a meter is relative to that, right? So all measurements are relative. There's a standard and you're making it relative to that. So if you want to get, theoretical, all measurements are relative. There's no such thing as an absolute measurement, right?
Yep. Just depends what you're measuring it against.
Yeah, exactly.
Yeah. Hassan, you've got your hand up.
Yes, there's a simple way around this problem. If you measure, let's say you put your, okay, so first of all, if the output of your amplifier is 50 ohms, you plug it into 50 ohms on your scope, you should be able to get an accurate measurement there. But let's assume that you're using a scope probe inside the circuit. The impedance at the point you're measuring it is not 50 ohms. So you don't know what you're measuring. One thing you could do is, I guess you could put a test signal of some kind, and like a calibrated test signal, 30 millivolts, let's say. You put that on channel 2, you got your real one on channel 1, and you just compare the two. And then you might be able to figure out what the actual value is.
But that test would have to be at the specific frequency of measurement, right?
Yeah, absolutely. You'd have to be at one frequency only. In fact, the only way to do this properly is you've got to design test points into your circuit, and you've got to somehow pre-calibrate them somehow with maybe some golden reference or some golden standard equipment, and then you just do that. Or the other thing is you don't even worry about signal levels. You just look at the shape of the waveform and assume that the timing is correct, even if the amplitude is off. But it's never a simple proposition. Debugging inside a circuit with tiny signal levels is really tricky. So best to not even bother.
Yeah, Hassan, how big do you have any kind of idea how big of an error you would get by just measuring that? Is there any way you could ballpark that, or is that just that's the way it is? But is there any way you can...
So I've used like really expensive scopes in A&D with differential probes, thousands of dollars, and looked at signals, and I would always get like half the value that I should. And these are digital signals, so you know that like it's 1.3 volts or 0.8 volts, and I'm measuring 0.4. And so that's the thing you would look at. You can figure it out if you know the impedance of your circuit, and you know that your probe is going to add have a resistance of like 1 kilo ohm at that frequency. You could kind of figure it out with Ohm's law and stuff, voltage dividers math, figure out what it should be, but it's not even worth bothering. Just look at the signal at the inputs and the outputs, and in between look at the shape of the waveforms relative to each other, and that's all you can do.
But Hassan, if your circuit, I don't know if it sounds if you're driving, I don't know if you can see, but if you've got the circuit, you've got output impedance, input impedance, and you're going to put your probe into that place there. Now, if your probe has much higher impedance than the input or output impedance of that point you're doing, would that attenuate? Would that, because wouldn't the energy seek the least impedance path?
You're right, it does. And so if you have an infinite impedance probe, it doesn't load the circuit at all. And so what you measure is what you get. The problem is, even with an active probe, without an active probe, you're going to have an impedance of like a kilo ohm. With an active probe, it might be 10 kilo ohms or 3 kilo ohms. It's not much better. So the best way to do it is, here's what you do. You design test points, probe points in your circuit. Maybe you use SPICE to figure out what the impedance is at that point. Maybe you calibrate your probe so you know what its input impedance is at that frequency. And now when you plug it in, you know what you should get, and you have a way to calibrate it or figure out what you're really measuring.
So how would you design that test point?
You just go to SPICE, break out a voltage test point probe, put a voltage probe there, wire up a trace so it goes out to a convenient connector on your probe, on your board, and just do it that way.
Oh, so you're doing it. I see what you're saying. You're saying in like LT SPICE, see the impact of connecting the probe to that test point.
Right.
Okay, I see what you're saying.
And that's a good strategy in general, because probing a circuit is kind of tedious. And you're always going to be looking at a few points only. You don't need to know everything in the circuit. So you might as well just design it onto your board from the beginning.
But
Like
if you had,
well-designed boards have.
if you had a circuit, I don't know, between two stages of an amplifier, this is what we're talking about, I think. And if the output of one stage is designed to be 50 ohms and the input to the next stage down is also 50 ohms, and so you know that's the impedance to ground at that point is going to be 50 ohms in your circuit. And if you connect a probe that's got a much higher impedance to ground, like say 2K or something, then it's not going to load the circuit all that much, is it?
No,
The
it
higher
won't.
the higher the impedance of the probe, the less effect it's going to have on the circuit, right?
That's right. That's right. Having said all that, you only need to have 50 ohms when you're interfacing to coax. Inside a circuit, there's no point making it 50 ohms. You just make it whatever's convenient to use the least amount of resistors.
But you know, measuring, I was never worried about the measuring of the individual circuits throughout whatever, you know, making those measurements, because your 10-to-1 probe, you use the 10 times probe, you've got a 10 meg input on it, so you're not, loading down the circuit was never a concern, you know.
No, Peter, it's not 10 megohms. It's 10 megohms at DC. At RF, it's whatever the capacitance is for your probe.
Oh yeah, you're right. Yeah, right.
So it's like 10 kilo ohms or less.
Huh.
Yeah, I think that's in Dave Jones's video. That's what he was talking about. He was saying if you look at the RF going through it, it behaves totally different than a DC path, right?
Well, it's
And
a
that's
transmission
like-
line. The
that's
probe
that
is a
whole-
transmission line.
Yeah, that's that whole transmission line thing that guy, the guy did with the light bulb coming on. He did a 1 kilometer. That's basically what he was saying. At DC, that's going to behave differently than at AC. And when you first connect up the power, there's a transient, so that's AC. So then you can't just use normal DC math for doing it, right?
Yeah.
Yeah, it's worse than that. A 10x probe has got the cable capacitance, and then they add a known capacitance in. Like it's a 10 megohm resistor in parallel with the capacitor. And the only reason a 10x probe is used is because you tune the capacitor so that it's like, you know, it's like the capacitor provides your 10x impedance as well as your resistor.
Well, that's
so
what
your scope has got 1 meg on the input, and there's 10 megs in the probe.
9.
So a 10 to 1 reduction, and then you tune the capacitor in the scope, so the capacitor is also 10x with the probe wire capacitance.
This is
so
what
10 times.
This is what the compensation's all about, isn't it? That's how
right.
you compensate the probe, and what you're doing is you're making the ratio of the capacitances, the compensation capacitor and the cable capacitor, capacitance, right. the 100 picofards of the cable capacitance in series with it all works out, so it should be right, you would think.
Right. So the AC attenuation is 10 to 1, same as the DC attenuation.
Well, that's how you set up your probe, yeah.
But you're setting your probe up at like 1 kilohertz.
At what?
You're doing your probe you're doing your probe calibration at like about 1 kilohertz.
No, the probe calibration doesn't depend on frequency. The probe calibration depends on the capacitance of your cable and the capacitance inside the probe. So that's 10 to 1, and the DC resistance is also 10 to 1 because the scope has got a 1 meg.
Yeah.
But when you're adjusting your probe, you're hooking it up to a 1 kilohertz signal.
You're not. You adjust. Well, that's just for show, but it works at all frequencies. You calibrate it once, compensate it for one frequency, and the ratio of the capacitance is such that they will, at any frequency, they will always have the same relative attenuation.
Okay.
But it's also true that at the higher frequencies, the capacitive reactance is much higher. Let's see now.
That's right.
It's in parallel with the 9 meg and the 1 meg resistor, but
so as the
capacitance takes over when you get up to the higher frequencies.
That's right. So what happens is your probe, so at higher frequencies, your capacitance impedance is lower than 10 mega ohms. And so, but the key thing is there's no AC versus DC distortion. Because, I mean, it's still 10 to 1 in both cases.
But I'm not following. Okay, by just using the formula, 1 over 2 pi FC. If you're calibrating your probe at 1 kilohertz, and then you increase your frequency up to say 20 megahertz, your resistance is falling quite a bit.
That's right. It shorts. That's what we say. But Hassan, like there are two issues here. I see two issues here. One is loading the circuit, and two is accuracy of your measurement, because the cable and the probe attenuates your signal. Okay, there are two issues. So the first issue, could you just, in terms of not loading the circuit, could you not take a 1 mega ohm resistor and attach it to your scope probe and probe with that mega ohm? Because then it doesn't matter what's going in, it's all going to be attenuated 1 meg. So even if the cable and the probe itself shorts, it's still a 1 meg impedance.
You could do that, but you don't use 1 mega ohm. You use 1 kilo ohm or 10 kilo ohm.
Or
1 mega ohm.
whatever. But that would fix the first problem in terms of loading the circuit, right?
That's a poor man's active probe, right? Just a 10K resistor hooked up to an alligator clip and a 50 ohm cable, a BNC cable, and that works reasonably well. Problem is that a 1 mega ohm resistor, they don't use that. I think they use 10 kilo ohms, because I think a 1 mega ohm resistor still has some capacitance on it, which will be much less than a mega ohm.
Oh, right.
So to Peter's point, when you compensate a probe, you're not adjusting for amplitude. You're just adjusting for the shape of the waveform. You want it to look like a square wave, so the ringing goes away. So that's what you're adjusting. So you're never adjusting for amplitude variation.
Okay, I just did a quick calculation here. At 1 kilohertz, using the 18 picofarads on the scope, all right, you will come up with about 8 meg will be the capacitive reactance. When you get up
meg or 8 ohms?
Pardon?
You said 8 megs. 8 ohms or 8?
8 meg ohms. 8
meg ohms. Okay, got it.
When you go up to 20 megahertz, the resistance falls to 442 ohms.
Right. And an active probe might make it better by a factor of 10, so it'll be 4 kilo ohms.
That's why it rolls off, Peter, because at a higher frequency, that capacitance acts as a short. So that's why you get the roll off in frequency at a higher. It's like a band pass filter, a low pass filter, an RC low pass filter. The capacitor is shorting it out as you get higher in frequency, right? The capacitor is shorting out all those higher frequencies, or not.
No, it's the other way around.
Do you understand what I'm saying?
The roll off was at the lower end, like 1 megahertz, 2 megahertz, 3 megahertz.
No, but what the calculation you just did?
I know.
But that's the roll off for a capacitor to ground. That's like a capacitor at ground. It's rolling off, right? It's like a low pass RC filter, right?
So what he's saying is that to use Peter's example, at the higher frequency, instead of your scope input being 1 meg, it's actually more like 400 ohms by that calculation, because it's the 18 picofarads of the scope input to ground.
Actually, I didn't do that right. I only used the input the capacitance of the scope and not the probe itself. So you'd have to add that in as well.
You'd add 100. So you're looking at 18 to ground plus 100 to ground for the scope, for the 3 feet of the scope cable.
Well,
it was 118, not 18.
So it's 85 picofarads on the 10 to 1, right? So
See, Michael, that's what Dave Jones was talking about in his video with these
Yeah.
probes. He was
That's
showing
right.
that the
That's right.
probe, even though your scope is 100 megahertz bandwidth scope, your probe is bringing it down to like a 20 megahertz scope.
and
That's right, which goes back to why, that's part of the argument as to why you can only use, let's say, a 200 meg scope at a much lower frequency with some kind of with reasonable accuracy. That's sort of why.
So using the 100 picofarads at 20 megahertz, your resistance is now down to 80 ohms.
Yeah.
Right.
I wish I never brought this up.
So your active probe is going to have to boost the signal at those frequencies to normalize it. Right? It's going to have to do like what the SA is doing with the normalization. It's bringing it and it's normalizing it out.
Yeah, I never looked at what the capacitance of an active probe was.
It's the capacitance of the input of the MOSFET. So if you look at the gate capacitance for your MOSFET, that would be the capacitance. So it might be a few picofarads. But let's say it's 2 picofarads. What does that give you?
2 picofarads?
2 picofarads.
2 picofarads at 20 megahertz. About 4K.
Oh, that's perfect. That's
No,
probably what
typically,
you get.
Hassan, isn't the input capacitance to MOSFET hundreds of picofarads, hundreds of puffs?
I mean, it depends on the MOSFET. I mean, I'm assuming it's an RF MOSFET, surface mount, et cetera, et cetera.
But you've also got to think about what's on the other side of that MOSFET, right? Between where your probe is and the MOSFET. There's presumably other capacitance in there as well. But I don't know without looking at the circuit, but there must be. Yeah, you got to think about that.
Michael,
Well,
I'm going to be doing a presentation on MOSFETs coming up. But what I'm going to be doing is I'm going to be
What's a MOSFET? Is that like a mouse?
No. I've actually created a model of a MOSFET in LT Spice, and I'll show all the capacitance, Miller, and the input and output capacitance.
Interesting to see, yeah.
And you'll see how all that impacts the MOSFET. Because most of the MOSFETs we use, the IRF 510, they're typically under 1,000 picofarads. So it's around 400. You may get a good MOSFET down in the 50 picofarad range, right? But it's these MOSFETs are plagued with all this capacitance, which kills us at higher frequencies.
Well, I mean, cheap general purpose MOSFETs might be that way, but RF MOSFETs should have better parameters, shouldn't they? But to Michael's point about the output of the MOSFET, if you design your MOSFET with a 50 ohms output impedance, plug it into a coax cable, then it will not have this problem.
I'm just looking at the capacitance of the MOSFET that Mr. Carlson used, and it's the typical value is about 5 picofarads for that MOSFET.
Which is that? Is that CIOSS or input?
It's the 3SK74.
No. What's the capacitance? Is that the input or the output capacitance?
Input capacitance.
Okay, yeah, that's what you got to, because that's the Miller and that's the VGS, the gate to source and the gate to drain capacitance. That includes both.
Okay, so that's 5. So at 20 megahertz, it's 1.6K.
Yeah, that sounds reasonable.
So what do we do now?
All right. So I guess the question is, why do we use MOSFETs that aren't, I mean, is it price?
Purely cheap, purely
Yeah.
cost. Compare RF MOSFET to IRF 510. You know, a RF MOSFET is probably tens to hundreds of dollars, whereas IRF 510 is like 50 cents a buck.
Oh, it's that much of a difference.
Oh yeah, it's
those are
huge.
power MOSFETs. Those are high power MOSFETs. For small
Yeah.
signal ones, they should be like just as cheap.
No,
I think-
I've been pricing them out, Jason, trying to find a RF MOSFET that does power. And
You don't
it's
need high
expensive.
power for this. You need you
No,
don't
no,
you
no,
need
no,
like
no,
a
no, no. Yeah. Different conversation. With
Yeah.
me, yeah, I should qualify. What I'm looking for is a MOSFET for a power amp, right? So I was looking for something that has low capacitance but could handle a ton of current. And those things are expensive.
Yeah, of course. Those are on the output stages. You don't need to. You wouldn't even use a MOSFET. Use a HEXFET or a different device. But for the input side, you need a small signal device. So it should be just as cheap as the other one. The other thing is, if it's surface mount, it has less input capacitance as well. Discrete parts have higher capacitance because the input metal pins are larger, etc.
And I guess the leads too, right?
The leads, that's what I meant, yeah. But that's why active probes cost thousands of dollars. They're more expensive than the scopes themselves.
Not the POA active probe. $10.
So do
$10.
do these active probes compensate for that roll-off at higher frequencies? It's going to automatically adjust to level off the signal at higher frequencies, or it's something you manually have to go and tweak?
I don't think they adjust for anything. Basically, even with an active probe, you're only going to look at the shape of the signal. You would never use it to do signal strength, amplitude level measurements.
So it's just,
Why not? If you're getting a better,
because you're still going to have the roll-off. That's what I'm asking.
but there might be less roll off with an active probe.
No, the cable's still going to roll off. You don't have a 50 ohm cable. Your scope is not 50 ohms. If your scope is 50 ohms,
Oh, you have to terminate your scope with a 50 ohm terminator. I said that at the very beginning. When I first talked about active probes, I said you have to terminate with a 50 ohm terminator. Although
yeah, the cable.
no, but then would not, you still got that internal capacitance within the probe, which is going to short out at higher frequencies. You still got
Dave, no, because what happens is your MOSFET out is a small amplifier with a 50 ohms output feeding into a 50 ohms cable. There's no attenuation of anything at that point.
No. But once it feeds into the scope, inside the scope, it's got a capacitor. It's got capacitance to ground, right? And that's going to short out your signal.
Yeah, that's only for your high impedance input, your 1 meg and 10 meg inputs. If you use 50 ohms input,
Right,
there's no problem.
yes. Yeah, but we don't have a 50 ohm scope. We have a 1 meg. That's my point.
But
right?
you use a T with a 50 ohm
Well,
terminator.
exactly. You put a 50 ohm across the termination. You put a 50 ohm resistor across the input.
No, it's going to short it because, okay, it's properly terminated, but now you're putting an 18 picofarad capacitor to ground. What's going to happen?
I see your point.
It's going to short. Yeah. It's going to short it up. It's still going to roll off.
I guess
so now is my question: can the active probe compensate for that roll off? Because
I see what
you crank up the gain at higher frequencies so it stays level, right?
When what's his name? I forget that. Not was it Dave? Whoever was talking about these? Yeah, it was Dave Jones when he's talking about these probes. I didn't go through the whole thing, but the point he was making was the reason you use it is for safety. So you can avoid blowing up your oscilloscope by putting it in the wrong place in a circuit. That's sort of what I got out of what I heard him say
Oh,
in
what are you
terms of
talking about?
why you would use an active probe, but I didn't follow things all the way through.
I
So
think-
That was because of the differential measurement.
I think
that's right. That's what he was talking about, putting your probe terminals across an element inside the circuit, and he's saying use an active probe. It's safer because it's isolated.
That's right, because
Yeah,
your regular probe will short out your circuit if you made a differential measurement.
Well, you could do the same thing with a one-to-one transformer, right?
Yeah,
So
that's right.
use a
You
really
isolate
high-
your scope with a one-to-one transformer, and then it's the scope itself is floating. So then you can use it however you wish in a circuit.
Because then you can have DC going through, but you won't you'll have AC going through, but you won't have DC. But I think Hassan's right. I think I'm starting to see his point now that an active probe is only used to see the shape of your signal. It's not used to make an absolute measurement. You could make a relative measurement the same way we would go and use a regular probe, but that regular probe might load the circuit. The active probe does not load the circuit.
Right.
I
Not
don't
as
see
much.
why
Yeah.
you cannot make an absolute measurement with an active probe.
You can't, because the internal capacitance of your scope, because we've got a 1 meg scope, okay, that internal capacitance of your scope is going to short it to ground. It's going to roll off with higher frequencies.
But your regular probe is going to do the same thing.
Right, exactly. That's
So my point with an active probe is that the active probe is probably a less of a problem than a probe.
It's going to be the same thing because it's your scope. We've eliminated the probe, the cable and the probe. The issue with the cable and the probe, we now still have the frequency roll off in the scope.
Because the scope has an 18 picofarad capacitor to ground, nothing you can do about that. It's right at the so it doesn't matter what kind of probe you use, you're still going to have the 18 picofarads to deal with.
That's right.
At the higher frequencies, it's gonna knock down the amplitude.
That's right. And so that's why I was saying the active probe, you got to have some way where you can go and adjust the gain to pull it up at that higher frequency so it's normalized.
So how
This is very depressing. It makes the whole issue of measuring anything.
I know.
How do you make accurate measurements then?
Well, yes, exactly. Why bother? Why not just trash our scopes?
No, but I think that's what Hassan was saying. You could look at the shape, or you could make a relative measurement, and I think that's what you were saying, Michael. With the LBS amplifier, at that frequency, you're looking at input to output, so any kind of attenuation cancels out, right? So,
yeah, that's right. I guess that's right.
Relative measurement that's a lot more accurate than an absolute measurement.
Yeah.
So Dave, one thing is if you want to compensate the amplitude for the internal capacitance, that has to be done. That's frequency dependent, so that doesn't work. So what you would have to do is, you could do the same trick where you have a known capacitance on your. The best approach is use a 50 ohms input. Avoid the problem completely.
Yes.
If you're hooking it up to a 1x probe, then you got the 18 picofarad capacitance to deal with, and that causes attenuation. So you put a tunable capacitance on the outside and do the 10x attenuation bit, and now you can tune away the internal capacitance of the probe, just like you tuned away the capacitance of the cable before.
I don't understand. Dumb it down. I don't get it. You got to dumb it down, man.
Okay, here's the thing. You've got this fixed unknown capacitance in your scope, right?
Yep.
So how do you deal with it? Well, you put a tunable capacitance on the outside of your scope and tune it so it's 10x it's 10x what it is on the inside. And now you can basically your attenuation is fixed. You no longer have a variable, an unknown attenuation. You have a known attenuation of 1 to 10.
Because a capacitor in parallel adds in series.
Well, a capacitor in series is a voltage divider, but yeah.
Yeah, no, but if you put outside your your scope input, you put a capacitor to ground.
No, in series.
Series.
But if you put in series, you have a voltage divider.
Well, that's what you do. That's
What
10x
you have to do to
attenuation.
lower to lower the capacitive reactance, you would have to put the capacitor in series.
You're not trying to lower it. You're trying to compensate for it. So you attenuate the signal by, and then, it's a known attenuation. So you still attenuate, but you attenuate by a known fixed amount that you've tuned. So it's 1 to 10. That's how probe compensation works.
But Mr. Carlson, he put his tunable capacitor. He shows his tunable capacitor going to ground.
So he's got it in two capacitors.
Because, you see, that makes sense to me, because if it's in parallel, Hassan, if the capacitor is in parallel, you're adding the capacitance to the capacitance in the scope. So you're increasing the capacitance in the scope.
Yeah, which is pointless. So you have to. Where does he have it? He has it in
Right
series.
here.
That's his.
This is his coax. There's his tuning capacitor, and there's his 50 ohm terminator he's going to put on the end of a T on his scope.
That's different. He's tuning out the capacitance of the cable. So he's got a voltage divider with the cable cap and the tunable cap. That's different. But okay, whatever it is, you put a tunable capacitor, you tune it out. That's the upshot. It depends on what you're tuning out. Dave was talking about tuning out the internal capacitance of the scope.
Right.
Yeah, exactly.
But the goal is you want to have a voltage divider with a fixed capacitance you can't do anything about, and a tunable capacitance, and you got to make a voltage divider with a capacitive divider, basically. That's what you have to do, and then that way you have your attenuation is constant across all frequencies. That's the goal. When you have you have a capacitive divider, your attenuation is constant across all frequencies. That's the goal of this whole thing. That's the point.
But how could a capacitor, because by nature of a capacitor, it's got a roll off.
Yeah, so you have two, right? But now you have another capacitor down there, and they have a fixed ratio. So at all frequencies, how does it work? If you do the math, I'm sure you should get a constant 1 to 10 attenuation at all frequencies.
You would choose a capacitor such that at the 3 dB point where it rolls off, it's going to introduce a fixed attenuation from that point on. Is that how it works?
I'm getting confused now.
Your head hurts. My head hurts. Welcome to my world.
Let me think. You've got your roll off, and now you've got a second capacitor there, and just write out the equations of the capacitor impedance, and I don't know. It should work out. I don't.
Anyway, you know what? We're killing it, man. I think maybe we should move on to something.
Okay,
I think people are getting bored and they're going to start leaving soon.
There's one more thing that Peter mentioned about why you can't do an absolute measurement. I think the problem also is the circuit itself. You can do this for one point in the circuit, and you figure out, okay, this is what it should be. This is what I'm measuring. I can apply a fixed scaling factor and understand what the real value is. Now you put it on a different point in the circuit that has a different impedance. Even if your probe was compensated for the first one, now you're at a different point in the circuit. It's all different. So you'd have to repeat this thing every single time you did it. So that's the other issue why it's
I like to forget about this whole presentation, because before I did all this stuff, my world wasn't broken. It's now. Sorry, guys.
All right. Well, Peter, I'd like to thank you for bringing up this topic. However, you are banned for the next 3 meetings from suggesting any discussion topics. I'm sorry to be the bearer of bad news, but somebody has to be the hangman. So just a couple quick things. These are much more, hopefully, easy questions regarding your presentation. But I guess the bottom line is this: was the initial point of your demonstration to show one set of probes versus another? Was that kind of like, is it quality of probes?
No. My original intent was to find out how the probes were acting in a circuit under a wide range of frequencies.
Okay.
And how were they responding to those frequencies?
Okay. So that notwithstanding, could it be used to show probe quality?
Well, I did. I also had, because what I was seeing with the Tektronix, with the Siglet
versus the Tech.
I also happen to have a Tektronix probe as well, so I did a quick scan on that one, and it showed the same kind of characteristic curve. It just wasn't quite as dramatic as the Siglet.
Right. And correct me if I'm wrong, but what would you use to fix the impedance mismatch there? Would that be like an L match circuit?
What, on the scope? To make a
like that Dave was talking about with the impedance. How would you?
Oh, I'd use this, and then I put a 50 ohm terminator on one side. This would go into the scope, and then my probe would go into the other side of the T.
That's all. And what was that little device called?
BNCT.
Oh, okay, that's it.
Yeah, they're just a.
And that will match your impedance.
Well, you got a 50 ohm terminator on one part of the T. This part here goes into the scope. The 50 ohm terminator on this half, and then your probe would go into here.
Or one of these.
Pardon me?
Where is it? One of these, which is just connected directly in series. There's a 50 ohm impedance to ground on this one.
Yeah. There's a
BNC. This goes into the scope, and this goes to the other side goes to your probe.
Okay.
Same thing.
It
works the same way.
Yeah.
Huh.
Not cheap either.
All right. And you should be able to measure the same kind of thing with even a tiny SA, right? You don't have to blow $1,000 on a Siglet analyzer, right?
Well, I gotta learn. I've had the tiny SA for probably a year now. I never used it, so I'm gonna have to figure this out.
Well, that's what I was saying before. If you have an SA or a VNA or a tiny SA, try it, or even the PARC SigGen.
Yeah, I'm gonna do that.
Which is what I did, because after I went through all that, I got curious. So I'll break out the SigGen, the PARC SNA. The only thing is, I had to copy all the values down by hand because I couldn't get the CLI to work.
By the way,
I'm scared to ask what a CLI is for.
Oh, the command line interface. It's just so you can output the data from the PARC SNA directly onto a disk.
Oh, okay.
Or right into a spreadsheet, whatever. So you don't have to write all the numbers down. All the data comes out from your waveform.
Another thing to explore.
Peter, here's an idea. If you have a circuit, make a bunch of test points in it where you might want to probe it, figure out what the impedance is at that point, and then characterize your probe so that you know what its impedance is. And then just print out a table saying that if you measure this value at this point in the circuit, here's how you got to correct it.
Right.
And no one's done that before, but that would be a very clever thing to do.
Yeah. I know we're flogging the horse again, but it'd be interesting to know what it might be a worthwhile exercise, a tabletop exercise, just to calculate out the math and just see what difference it does make. I mean, the relative measurements are important, so that would succeed. You don't need to worry about the compensation, although when you're using a 10-to-1 program. Oh no. Let's go to another subject.
All right. Well, it was good. And, I think you achieved your aim, as you had mentioned earlier, about generating discussion. So, mission accomplished. All right. So I think that was really the only not presentation, only discussion topic that we had on for this evening. So
I thought you had an LT circuit to show.
well, I did, but unfortunately, that, like I said, it's going to have to wait for a couple weeks because all I got through was half of the tutorial. So I'm afraid that that's still under development. So that brings us to, I think, our round the screen discussion here to see what is everybody's working on. So as it happens, I see a sheet of plywood attached to a wall behind the first person who's up to tell us what's going on in his workshop.
Haven't I talked enough? You guys want to hear me talk more?
Just a little brief, everybody's curious now.
I'm bored. I got nothing else to do. I'm not working, so I decided to renovate the workshop.
You just built it 3 months ago.
I know I'm bored. I'm throwing. No, it was just a mess, and it's not organized well. So that plywood at the back are going to be mounted, like I'm going to be putting to. It's just not organized very well. I have stuff in bins on the floor and stuff lying around in tabletop, and there's no storage. So I'm trying to organize things a little bit better. And plus I have to put a spot for my 3D printer. I don't even have a spot for it. So I'm trying to make a spot that where the table is relatively stable and it doesn't oscillate when it's printing. So stuff like that. I'm just trying to get things more organized. V3OI clear.
Okay, Dwayne, what's keeping you busy over the last 2 or 3 weeks?
Been playing around with the router for trying routing out, circuit boards and comparing them to what I can do with toner transfer, and come to the conclusion that I'm going to use the little CNC engraver to go in, drill holes in any through hole parts, and then use toner transfer and use that for the actual etching. I've been able to get much more consistent results doing that. Also playing around with I'm wanting on some other stuff like that, since I'm going to a lot of straight surface mount stuff. I've gotten to some of the boards I'm doing like that. I'm probably going to write up a little tutorial on using toner transfer to etch the boards, to make solder masks, and to make SMD solder paste templates out of the same artwork. And besides that, today I managed to bottle 3 bottles of ginger wine that I'll have to let set around for a couple of weeks to see how that works out. And that's it.
Nice. Yep. I just opened our first bottle of a stout that we made that was supposed to be ready for the holiday season, which it was. I just didn't get around to it till the new year. But anyway, a nice stout was had. It's a chocolate vanilla, and I must say I'm quite happy with it. So enjoying it up here at the cottage. So doing a little brewing myself too with a friend. So, all right, Frank, what's on your workbench these days or otherwise?
Okay, we'll turn something on here. And over the holidays, I got a little curious about a subject that was kicked around quite a bit on the reflector there. It was about whether the energy flowed through the wire or around the wire. And I'm not a physicist, I'm not an engineer or anything. I'm just a curious home brewer and a hobbyist. So anything I get like that, I usually would do a mock-up myself. So I decided to prove it. Does the energy go on the outside of the wire, or does the energy go through the center of the wire? And to do that, I worked a little jig. There's a simple plug that goes into the wall, and at the other end parallel. Okay, little plug that you can plug a table lamp into, and the two are connected 1 to 1. Except when I get near the end, I've got a little bypass here. So one wire goes straight through, and the other wire has a connectors, and so it's separate. So what I did then was take careful notes, of course, and plug the plug into the wall socket and plug the lamp into the other end, and the lamp came on. And then I took my hand. Of course, I was careful to use the right hand, and I hung on to that piece of wire, made notes to whether or not I could feel any energy going through the outside of the wire. And I definitely did not feel any energy there. And then I just connected that wire through the two different clips, and I put in this one right here. What it is I've just taken the same length of wire, but I bared the inside. I took all the insulation off of it and then connected the other two ends to the MAR connectors, right? Then I had someone else put the plug in because I was going to be too busy taking notes. So I put my hand around there, and I can tell you that definitely the energy goes through the copper wire. So
I'm glad you're still here, Frank.
Yeah.
And you've got a normal sinus rhythm too, right?
Yeah.
The old ticker is back into its good old pitter patter.
You know what, Frank? I think you need to tell Electro Boom what you've done, because he could make an exciting video out of that methodology.
My conclusion was, I think our friend Dave Jones should stick to writing April 1st articles for electronic magazines.
Well, I would say that is the true spirit of what this hobby is all about, is figuring things out for yourself and touching live wires.
And
I think you
electrifying.
can try that at different voltages now, Frank.
noticed-
and adding some phases in.
And edifying, or was that electrifying experience?
Yes, very much.
I noticed Frank has less hair.
Yes, right.
And what's left is much curlier than it was last month.
Frank, it reminds me of that joke about the philosopher who was arguing. People were trying to argue that motion is impossible. So he jumps on a rock and says, "I refute it thusly." He jumps off a rock. It's called solvitur ambulando. It solves by walking.
Maybe next time I'll describe my circuit for a smash gap rectifier. That's kind of entertaining as well.
All right, noted. Thank you, Frank. All right.
Have it ready for the 2 weeks' time, Frank.
Yeah.
All right. So Hassan, you are next on the list.
Okay, so we were talking about gunplexers, and Peter asked me if challenged me to get it ready for another meeting. So I went online and found some for sale, and the guy happened to be in Mississauga. So, I mean, talk about going down the rabbit hole. I went up the rabbit hole in this case. So I bought some gun diodes. They were pretty cheap, and then I talked to the guy, and he's like, "Oh, I've got ready to assemble modules for sale." So I went and bought those as well. So I don't have to actually figure anything out now. I ordered them. They're going to come in about a day or two, and I have about 3 or 4 gunplexer transceivers, which I can just hook up and try them out. So all you have to do is hook up 8 volts DC to the transmitter, and you can just modulate it with CW or whatever. And on the receiver side, you just tap off the signal and pipe it to a speaker or a scope or whatever, and it just, everything's done inside. The modulation, demodulation, it's all handled. So hopefully might actually get this up and running, but touch wood.
Okay.
So if anybody wants them, the guy's got a whole bunch for sale on eBay. I can send you a link to anyone who's interested.
Sure,
They're
maybe you could put
$30
that
each.
in the chat.
Sure, I'll have to dig up the link, but I'll mail it to you guys.
Okay, or post it in
On the
the
reflector
groups.
groups IO.
Yeah, I'll put it on Groups.io.
Okay. Thanks for that, Hassan. And now we've got Michael. You're next on my screen here.
Yeah, well, I haven't been doing much. We went to Montreal for Christmas, so I haven't done a lot of stuff, but I did make one CW contact today. First time in a long time. But over the holidays, I got my 40-meter DXCC logbook of the world stuff all organized and submitted that. Now I got 40-meter DXCC. And the other thing I've been doing is working on this Smith chart presentation, which I'm getting there. It's been an educational experience, to say the least, and I've learned a lot. So that's the plan for, I think, the next meeting, right, Peter? Is that what we're doing?
I think so. Yes.
Yeah. Okay. I'll be. It's virtually done. I've been using the Nano VNA and to get some stuff, and I've also got a piece of cable here that I've been fiddling around, measuring impedances and whatnot, and putting it on Smith chart. So I sort of know what I'm doing, more or less. I hope it'll stand some level of scrutiny anyway. Hopefully. That's really all. Not much.
Okay, Michael, Frank put his hand up while you were talking. Frank?
Yeah, Michael, just your 40-meter DXCC, what mode was that in?
Well, I think about 80 QSOs would have been, well, mostly CW, because I haven't got it. I just haven't done anything on 40-meter sideband. So about around 80 countries would be CW, I think, over the years. And the other 22, I got 102, would be FT8, which is a lot easier. I don't have a very good 40. I've got the R7 vertical, which is it's tuned for the sideband portion of the band, but with my tuner, I can get it down to the CW portion. So nevertheless, a good part of the stuff I've done recently has been FT8.
Okay.
So yeah.
Congratulations on the CWs.
Yeah, well, I've got DXCC on all but 80. I've got magnificent 25 confirmed countries on 80, and I've got even better on 160. I've got one.
Mm-hmm.
So what I'm going to do for 80, I think I can't. We have a semi, so my backyard's 30 feet wide and 45 feet long, so there's no way I can put up an 80-meter antenna. I do have a DXB, but it doesn't work very well. So what I'm going to do ultimately is use the MIS Club Station's 80-meter antenna remotely. That's the plan anyway. We'll see how that goes.
Okay, thank you.
So maybe one day I'll have 80-meter FT DXCC, but very unlikely, I think.
All right, thanks very much, Michael, for the update. Peter, if I dare, do you have anything other than scope probe measurements on your bench these days?
I was going to start populating the board that I that I milled a few weeks ago, but I started to take a closer look at it, and there was a couple of errors in it. And long story short, I decided just basically redesign the board, and which took me back to KiCad, which then I had to make a couple of footprints for some of the chips that was not in the standard library. So I've been messing around with that and just changed a few things around the board. I'm at the stage now. Well, it's been this long. Why rush? So I might as well do it right. Originally, I was going to have a breakout board for one of the chips. I've changed my mind on that. I'm just going to actually mill the package size that it comes in. So anyway, that's kind of really all I've been doing of late. And speaking of DXCC, one of our local hams here just got his DXCC on 6 meters. I think it's all FT8, or the majority of it would be FT8, but nonetheless, 6 meters is an interesting band. That's it for me.
Okay. I think I actually have seen a little more chatter about milling PCBs just on the internet in general. I'm not sure where, but it seems to be gaining a little bit of traction as far as the mills to do it.
Yeah, I think it's going to do the job. I'm not so sure I can get an SC70 packaged very well, but I have an idea how I might be able to accomplish it. But anyway, we'll see. But I think I can get small enough that I don't think I'll need to go back to the chemical method.
Yeah, I think that's the key right now is getting things to a small enough scale, right?
Well, originally I started off with that package size, the real small ones, thinking that if I figure that one out, then all the rest would be easy. The trouble with that approach was that it's a difficult package size to mill, especially when you don't know what you're doing. So once I decided to go back to the larger size stuff first, then it went much smoother.
Yeah, it's hard to say. Maybe eventually laser is going to be the way to do it,
Well, let Dave explore that one.
Yeah. All right. Thanks, Peter. So, Kevin, you are next up. When you had your video feed on, oh, there it's back again. I just wanted to point out, it looks like you've got a monolith in your office now. Are you aware of that there? Have you tried to put your hand on it or whatever? Is it making any kind of weird noises?
No, I have my monitor set up in portrait mode. So
okay.
Just because, they're high enough resolution and all that. And
right.
And actually it has, if it comes up, it has ham clock running. Whoops.
Oh, okay.
So anyway, I can put more stuff on it, I find that way, and it just works better for my desk. Anyway, no, I haven't, I worked over the entire Christmas break, so I really didn't do anything. I just lived vicariously watching all you guys do your stuff and and listening to all your trials and tribulations. And I'm glad I didn't try and test any scope probes, Peter. I think it would have just doubled the conversation. So I think we should be happy that nobody else did that. But anyway, no, other than that, no, and Hassan, I saw your thing about the gun diodes, and yes, I do want to order some. I just haven't got around to it. So that looks interesting. So anyway, future stuff, but otherwise not much now.
Okay. All right, sounds good. Let me just get back. I've lost the grid here. There we are. All right, Wayne, what's going on in your neck of the woods?
Well, if the question is what's on my bench, it's actually most of my ham Radio Shack. I think the last time I was here in this conversation, I mentioned that I had managed to tap my foot through the wall underneath my desk of my shack. And it proved to be a mold issue. And it was a scary enough mold issue that I had to call somebody in to take care of it. So that involved us basically taking everything out of the basement area where I normally do my work, shoving everything into the lab, which is where what I call my workbench area. And then we had the team of people come in, and what they did was, they probed around to see if they could see where the mold was on the outside. They cut a 2-foot tall strip about 10 feet along the basement wall, peeled it back, and remediated it by just removing all of the moldy materials. It turns out I did not have any cracks in my basement, but it was centered around my regular shack. So the gentleman who came in suggested it's probable that it was the desk sitting up against the wall in the basement that might have been the cause, because when you have something against the wall and there's a cold, moist concrete wall behind, some fiberglass behind, some vapor barrier behind, some gyprock. It's just basically going to want to give some moisture through all of that, and it wants to come out, and it'll come right through the drywall itself. But under normal circumstances, it will not cause any problems because it's just vapor by that time. But apparently, the way I had constructed it, there were two things going on. I had put up a kind of like a fiberboard backing to my desk that I attached a lot of power supply equipment to. So I had the general big plug. I had the bunch of wall warts. I think it was just generating a little bit of heat. So the combination of the heat against the wall and the lack of air convection led to the moisture buildup, and that's what caused it. I'm telling you all this because I'm looking at what Dave's doing in his basement. He's putting up, looks like he might be putting a nice 4x8 piece of plywood against your wall. What I did find out while I was reading around, like why do I have mold? It's a lot of people who claim to be contractors in the buildings trade have issue with the building code. They think that in basements you shouldn't use vapor barrier, which is code. You should not put vapor barrier down because you don't like is the root cause of mold in basements. Basically, there's no place for the moisture to come in. So that's what my life's been like. Now I'm just beginning to put my basement back together. So I don't have my shack in yet, but at least I have a table there back again.
Wayne,
and I have a nice strip.
What was the symptom? What did you actually see with regard to the mold on the wall?
Where I found it, it was just basically black on the inside surface of the drywall, and it was coming off. And it was, like basically enough for me to say this is not something I'm going to try to touch. So I had it remediated. It's kind of cool, very space age. They put up plastic everywhere. They put on the special gear, and they just cut it out, put it in bags, and carry it off for you. So I still have the hole. That weight's still spring.
Needless to say, you're going to have some spacers in between the anything that goes up against the wall from now on, right?
Yeah, fan, stuff like that. I have to figure it out.
Yeah.
But,
I remember I had a similar problem several houses ago, and I ended up remediating it myself, doing something similar, cutting out a foot or so of the bottom of the drywall. But I ended up just replacing it with pegboard as it happened at the time, and then just painted it the same color as the wall for the bottom strip, so that it always had convection going through it. So it seemed to work.
Yeah. Well, that's my life.
Okay, there we go. I think my screen is reorganized a little bit here. So Al, you have popped up to the top of my screen now, but you would be next.
Okay, well, happy New Year, everyone. I haven't talked to anybody, but good to see everybody here. Oh, it's been a busy holiday with family commitments. Haven't done a heck of a lot. I'm still working away on my Strat QRP watt meter / SWR meter. I was playing with PC boards until I broke my hot laminator. So right now that part of the project is on hold till I either fix or replace that. I guess they really are only intended for laminating paper documents. So anyhow, we'll figure that part out. More recently, just to get away from a little bit of the frustration, I turned my attention just doing some of the hardware on the unit. I've been playing with the box, so you can actually see it's starting to come together. Nice little Altoids tin there. By golly, this stuff is tough to work with. It's so thin that you try to cut it and you bend it. The display here is kind of interesting. It's this thing has these 1 inch, I don't know if that's in focus, there it is, 1 inch OLED displays, and they're a bit of a challenge to put into a case. did a search and I found some bezels available at $30 in the UK plus shipping, and I was too cheap to go for that. So what I've been doing is went into the machine shop, and I've actually been making bezels out of aluminum with a recess in the back, and so that nicely holds the display in the back. Is that in focus? Yeah, there it is in focus. And we'll go into the case with a nice shoulder. So I think it's going to end up looking rather nice when I'm actually done. So that's what I've been up to the past couple of days. But yeah, getting the hardware and bezels, that's always a challenge to get it to look nice and professional. So the only other thing I was up to, what did we have in Mississauga here? 3 days before Christmas, we had that windstorm. Managed to bring down my my HF dipole, snapped it in half actually. So that was a bit of a problem, but thanks to Santa Amazon, I found the solution. This is some wonderful juvenile fun, but I bought myself a tennis ball cannon. This thing's quite amazing. You stick a tennis ball down the barrel, you undo the back end, and give it a spray of hairspray actually. A couple of seconds of spray, put the plug back in, and the plug actually has a piezo fireplace starter or barbecue starter. And by golly, when this thing goes on, is that ever loud? I didn't get reported, no complaints. The authorities didn't stop by, but this thing is as loud as a shotgun. So if you ever decide to try one of these things, just be careful where you use it. But by golly, the first tennis ball I launched straight into the air. Never saw it come back down. It disappeared. I think it's up in the ionosphere. The second one, though, I aimed it through the tree, and I put a tether, some of that black parachute cord onto the tennis ball, and was able to lob it over the top of the tree with tremendous success. So I'm back on air now with my dipole. So if anybody ever wants to borrow it, I have one. It's quite useful and a lot of good juvenile fun with a great big bang. Anyhow, that's all I've been up to right now.
Wow. Well, you're definitely getting an invite over to a field day this June. So yeah, do you have to come with that? I could see much utility for that.
Anyhow, nothing else to report. So we're just proceeding along. So.
All right. Peter has a question for you, I believe, Al.
That wasn't a question so much as it reminded me. I built a few years ago. I built a potato cannon out of PVC piping. It's same setup as you, like the threaded hub at the back, and used hairspray, and it blew me away how far you could fire a potato. It was unbelievable, but it was a lot of, as you say, juvenile fun. The only thing was we were doing it in February up at Perry Sound. So it took a little while to get it going because it was so cold. So we ended up tucking the hairspray inside your jacket because I think the cold was not helping. But once it got going, anyway.
My area of Mississauga is fairly populated. So after the first shot, I was kind of sheepishly looking around to see if anybody had noticed me. Somebody in the apartments probably thought they were just shot. Anyhow, nobody stopped by. No police cars came to visit. I had my story that didn't hear it from me.
All right. Very good. I see we have some high risk things going on with Al and Frank's experiments here. So maybe you guys should get together and create a little channel or something. Yeah. All right, cool. Last is Cherry. We've got you to give us a little update on what's going on with you.
Okay, so last month, hope you can hear me clearly.
Yep.
Okay. So last month, I went to India. I spent couple of weeks there and returned last week. And while I was there, I was, tuning with my shortwave receiver, trying to listen to some stations. I did not have a big antenna there, not quite successful to listen to a lot of strong stations. Some of them I copied very well. And prior to that, I tried to work on my Kenwood TS480. Sometimes on the weekend, I tried to work with some stations over the 20-meter dipole I have. I have to improve it. It's not tuned very well, but it's working with the antenna tuner. And I have some plans for homebrewing, but it is not really taken off. I'm collecting some components and some PCBs, but not yet started on some projects which I want to actually get into. But still, I also want to work with some of the antennas I planned for my backyard. So I can hardly get 20-meter dipole horizontally inside my property, but I still want to see whether I can accommodate a 40-meter dipole here, at least an inverted V or something. So I have a ravine in my backyard, so I'm just thinking whether I will extend one piece of line to there and get a 40-meter dipole at least to the ravine and have some fun through through that way. So yeah, a couple of antennas is what I'm actually looking forward to get working soon, so that I can work on multiple frequencies and so on. So far, I only have 20-meter dipole. I'm restricted to that. I listen to other frequencies, but that's what is going on my side. And
you should consider looking at an end-fed antenna. I've had much success with that, and it doesn't really take a lot of space at vertical more than anything else. I have mine up in a 20-foot tree or so, lobbed over with a slingshot, and it's multi-band 10, 15, 20, and 40. So
in fact, thanks for asking about that. In fact, I have I have actually kept this winded and ready for the end-fed, but not really get on to it yet. And also thanks to Frank, who has provided some materials long back, but I'm still working on it. It has not completed it because of my some things busy at work and busy at home sometimes. So I kept the core ready, and with two of the cores parallelly put together, and I just want to actually complete it. Also, the box near me, I've been keeping it at my desk for quite a long time. From hope you can see it. Yeah, this box is from Lowe's, which I bought quite a long time back. It's a normal electric box, and I'm just hoping that I can complete the coil and everything pretty soon, and do the rest of the stuff. So that's that's also going in parallel, but something's yet to complete and lying all over the place.
Yeah, that's great. No, good. So you're doing the homebrew route for the antenna, which is super. So looking forward to hearing what your results are with that. I'm easily able to be detected on the reverse beacon network over in Europe with my antenna. Granted, I've got decent elevation here, but still, they're quite well performing. So keep it up. Yeah.
Thanks, and I wish everyone a very happy and prosperous New Year. Thank you.
Great. Okay, thanks, Jerry. All right, and that's it. I think we're down to 10 participants now. Oh, Al, you've got a comment.
Well, just a suggestion. This past summer, I made a couple of end-fed balance, 49-to-1 ratio, and fairly easy project. Maybe we should keep that in mind as a potential build-a-thon. You could do a full power one or a QRP one, but not a difficult project to make, and quite successful.
Mm-hmm. Yeah, I guess on that topic, we are going to have to think about buildathons. When was our last buildathon? That was, I guess, in the before times, right? So,
Where's the DC the direct conversion receiver at?
I
Ken
think
isn't here.
Ken did do some work on it, and I think he got it all figured out. Like he had Kelly do some updates to the board, some minor changes. I think it was more of from a physical perspective, layouts for some components, and that's it. Now I think Ken will be back in the swing of things for. Not sure for January, but I think he'll be back for sure February, so we can get a better idea at that point. But he might be available for the next meeting. I'm not sure though.
okay. All right. No, sounds good. So I think that is really about it for tonight. We're at the 2-hour mark now. So next meeting is 2 weeks from now, Wednesday, the 19th of January, for our regular meeting. Peter, do you know who's lined up for that? Do you have that at your fingertips?
Yeah, Michael hopefully will have his Smith chart presentation to go, and I'm going to do something on, I can't even remember what it is. I'm doing so. I'm going to talk about my CNC stuff, a little bit about that. And if somebody else has something to chat about, let me know.
My LT Spice demo.
Yeah, of course. Yeah.
All right. Okay. Well, thank you very much for everybody's participation this evening. Once again, Happy New Year to you all, echoing Cherry's comments. Happy, healthy, and prosperous new year to you all. All right.
Good night, all.
7-3.
Right. Goodbye.
Bye. Boom, 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 boom.
Yep. All right.
So what tutorial are you doing?
Elector magazine. You know
Okay.
that one from the UK? They had a 20-minute intro to LT Spice. So I got through about 2/3 of it, and it actually did, it was nice. It was concise, clear, showed all the basics, really. I mean, I saw that the producer of LT Spice, who's it? Analog Devices?
Analog Devices bought out Linear Technology.
Yeah, so they had a tutorial on their site, but it was for the 4th version of it from like a decade ago.
That'll be okay.
Yeah.
It's still when they go from 4 to 17, you won't
The
see
controls are similar. Yeah.
Well, it's identical.
Identical. Okay. That's maybe why they haven't bothered to update it.
Yeah, just look at it. It's all valid. And the guy who wrote LT Spice, Mike Engelhard, he left Linear Technology shortly after AD took over. So I guess there was not a meeting of the minds there.
Yeah.
But he apparently he frequencies the LT Spice Groups IO, and every once in a while. And the last time he was on there, he said he was writing a new simulation program, bigger and better than what LT Spice is. But who knows? He says he's going to make it free. It's not going to be a paid thing. So it'll be open source. So we'll see what happens.
Right.
But anyway, in the
Have you
meantime,
played around with KiCad much since you mentioned that you had downloaded it?
That's version 6, and
Yep.
I have not dabbled with 6 yet because I know 5, and I want to finish off this project in 5 before I move on to 6. And I think Wayne might do a presentation down the road with 6. He wants to do some more, I think, KiCad presentations, but he's waiting for version 6 to come out, and it just came out just I think on Christmas Day, I think actually. And
I
so,
saw a posting about it saying that there are some significant improvements in it. So
and it looks it looks different as well.
Yeah.
So Wayne did make a comment to me that it's a project that he had done. Actually, the one that he had demoed to us with a filter, it worked fine. When he ran it through the air checker, it went fine. But version 6 hiccuped. It said there was it generated a few errors, but usually those kinds of errors are clearance errors and all those kinds of things. So you need to address. But if you're using KiCad and you got a few errors in it, as long as you know what they are, and you're doing your own boards, it's not a big deal. But if
does it accept files directly from LT Spice? Can you export from LT Spice into KiCad?
What do you do? No.
Okay.
No. So no, you have to do the schematic a second time
from scratch. Okay. All right. There's no converter.
Which Sprat are you taking? What's the rig you're doing?
So it's a CW 5-watt CW transmitter only, and it's actually just on the second last one that it's that guy from Australia, Peter Parker, did a 3-pager on it, the autumn 2021 edition. So, and that article itself references back to a Sprat 82. I don't know what year that was from, but originally published there was a circuit that I guess was this G4RAW 10-minute transmitter. That was the original name of the circuit. So
that would have been Sprat issue 188.
188. That's correct. Yeah.
I think I have 188.
Yeah. Probably just a little bit further down your reading pile or whatever. But yeah, so he did. Peter Parker did some, substitutions for some transistors that are no longer available, and put an amplifier in it to bring it from its original, I think he said 200 milliwatts is all that the 10-minute transmitter. It's only got 7 components in it, but 200 milliwatts brings it up to 5 watts with the
of course, we'll never know. Can't measure this stuff anymore.
Sorry, can't measure?
Well, we won't know for sure what the power output is because we can't measure stuff anymore.
Right.
But you know what? If you need the reference back to Sprat 80, whatever, drop Frank a line because he's subscribed to Sprat, I think, for years and years, and he may have a copy of it. So if you need to reference back to it, he may photocopy that article for you. If you need it.
Or just order one of these Sprat, Sprat on a stick, right?
Oh, yeah. There's that option as well, yeah.
Yeah, they're not expensive, right? I mean, what is it? 5 pounds sterling?
So 5 pounds, you're probably talking about $8.
Yeah. I thought it was 25, but it looks like it's only 5.
If it's only 5 pounds, I mean, it's worth it.
Yeah. 4 pounds for postage. So.
Oh, 5 plus 4?
5 plus 4, 9 pounds delivered. Yeah. Whatever, 9 pounds sterling, it works out to about $20 or something.
No. Maybe 18. No, not even 18. I bet you 17 or 16.
Yeah. It's a pretty good deal for that amount of material.
9 pound sterling. 9 pounds, was it you said?
Yeah, 9 pounds sterling is
about $15. So you have about, because of the conversion, when you have to do the conversion, there are probably another couple of bucks on top of that. Under 20
15 Canadian, yeah.
Under $20 for sure.
Right.
But that's good.
Yeah, that's a steal.
Yeah, I'm gonna take a look at that circuit. I can't get the I've looked at the schematic that I've done in LT Spice a couple of times now for that Pixie version 4, and but I can't get it to work.
So you're saying like the model in Spice doesn't work?
Yeah, like I built the rig in the Pixie in Spice, LT Spice.
Yep.
But when I run the simulation on it, I can't get it. It doesn't matter whether I key down or not. I just can't get it. It doesn't do anything. Well, there's a little bit of an output, maybe 6 millivolts output or something like that, and it doesn't matter whether the key is down or not. It's the same thing. So I don't know what's going on with it.
Are you doing that from a physical Pixie you have that you own? That you
I did take delivery of a Pixie kit just the other day, so I haven't built it yet. My idea was to put it this circuit, because these Pixies are really cheap, right?
Yep.
Like The other day, a guy was telling me that he saw one on eBay for $3. I think I paid 6 or 7 or something.
Yeah,
like
yeah.
that. So I
Especially
thought,
buy them in 10 packs or whatever.
you know, buy it and build it and see what it's like when you, and then see how Spice says it's going to run. Well, right now, Spice says it's crap. It doesn't work at all. Now,
Did you
whether
build it
the-
from scratch in Spice, or did you cobble it together?
What do you mean?
Like the circuit in Spice, did you draw it from
Oh,
a
yeah.
blank slate?
Oh, yeah.
Yeah. Okay.
Yeah, you have to. How else are you going to do it?
I just thought maybe either you found a demo file or something.
Nah, I did a search later on today just to see if somebody had already done one, but nobody has. Or if they have, they haven't publicized it.
Yeah, like is there a Thingiverse for LT Spice circuits?
There is well, you just have to Google it and see what you find.
Okay.
You may want to join the LT Spice Groups IO. There's some pretty smart guys on there. There's all kinds of things going on there.
Yeah. Well, I'm just wondering if there's no central clearinghouse for all of these where it's all cataloged and indexed. No, nobody's gone to that.
You just do a Google search.
Yeah.
And usually something will crop up. Usually you're doing Google searches for models for certain components and stuff. But there's a wiki for a lot of models.